In March 2026, the United States Department of Transportation and the FAA announced the Advanced Air Mobility Integration Pilot Program, known as the eIPP. Manufacturing leadership described the program as the sector's definitive breakthrough, a catalytic event they claimed would scale the industry for mass transit by the 2028 Los Angeles Olympics. Analysis of the federal guidelines reveals a different regulatory reality. The eIPP is a structured, pre-commercial data gathering framework, rather than a legislative bypass of aerospace certification. This regime of experimentation utilizes Title 49 U.S.C. Section 44807 exemptions strictly for early operational testing of aircraft still undergoing formal FAA reviews. The FAA has clarified that the program is not a mechanism to bypass safety requirements. Aircraft under this pilot program will not carry paying commercial passengers. An evidence map reveals the gap between these marketing claims and aerospace reality, auditing the specific data points for technical readiness, economics, and certification. True commercial scaling relies on aligning aerodynamic prototypes with lagging realities of battery chemistry, municipal grid constraints, and fundamental safety physics. Understanding the actual timeline for these vehicles requires auditing the engineering data rather than the promotional materials. Historically, the Code of Federal Regulations strictly prohibited aircraft holding experimental certificates from carrying persons or property for compensation or hire. Commercial flight requires a three-stage certification. First is type certification, which validates that the aircraft design meets all safety and performance standards. While manufacturers like Joby and Archer have completed major milestones, they are still working through mid-stage type inspection authorization testing. The second stage is production certification. This authorizes a manufacturer to produce duplicate aircraft, but it cannot be finalized until the type design is fully approved. Finally, operational certification establishes route-specific approvals and the protocols for airspace integration. The eIPP is a mechanism to crowdsource this operational data, distributing test flights across 8 regional corridors to inform the standards of the coming decade. This process subjects flight systems to exacting reviews, specifically the DO-178C standard for software assurance and DO-254 for hardware. The program is a coordinated effort to write the rules for the future, not a license to bypass the burden of comprehensive aerospace certification. The evidence map highlights a disparity between the physical airframes and the chemical energy storage required to power them. Domestic platforms have reached high maturity, with airframes operating at technology readiness levels of 7 and 8. The foundational constraint is battery technology. Current nickel-manganese-cobalt packs are lagging at technology readiness levels of 5 to 6 for commercial use. Specific energy density is the metric that dictates the viability of the business model, the measure of how much power a pack holds relative to its weight. Current designs like the Joby S4 achieve 235 watt-hours per kilogram, while the Archer Midnight hits 208. These sit well below the 400 to 500 watt-hour threshold required for mass urban mobility. At these lower energy densities, the battery pack comprises up to 27% of the aircraft's maximum takeoff weight. Under high-load commercial scenarios, standard cells often fail to maintain the mandatory 30% state-of-charge safety margin after completing demanding flights. Transitioning from a niche service to mass transit relies on bridging this gap with solid-state batteries, a shift currently placed in the 2028 to 2030 horizon. Public acceptance faces a separate hurdle. Marketing materials assert these vehicles are virtually silent and up to 100 times quieter than conventional helicopters. Absolute decibel levels are low. Official testing measured 45.2 A-weighted decibels at a 500-meter cruise altitude. However, NASA's 2026 Vanguard study revealed that residents in dense cities still report annoyance to air taxi sounds. This waveform illustrates why. Distributed electric propulsion creates a unique high-frequency tonal whine and complex blade vortex interactions. This high-frequency acoustic signature does not blend easily into the low-frequency background noise typical of major cities. While the absolute volume is lower, the unique psychoacoustic impact creates a community acceptance risk that has not yet been fully mitigated. The evidence map shows that physical infrastructure and airspace management are currently lagging at technology readiness levels of 4 to 5. The FAA addressed real estate constraints by basing landing pad geometry on a vehicle's rotor diameter, which allows for a more compact operational footprint. The paramount challenge remains the electrical load required for high-utilization fast charging. Adding a high-volume vertiport to an existing facility can create a 50 megawatt-hour per day load, effectively doubling the peak demand of some regional airports. This surge threatens to overwhelm local municipal utilities if the site operates only as a consumer. To maintain grid resilience, vertiports must integrate distributed energy resources, such as on-site solar photovoltaics and massive storage systems. These storage buffers allow for peak shaving, protecting the grid during charging spikes and discharging power back to the city overnight. True scaling requires redesigning the urban electrical grid into a bidirectional biourban system rather than just adding landing pads. The economic model for air mobility requires amortizing high initial capital expenditures over thousands of rapid flight cycles. Early passenger fares are expected to launch at $3 to $6 per passenger mile. Standard ground rideshare typically sits between $2 and $3. This initial premium aligns the service with luxury tiers, targeting corporate contracts and high-net-worth commuters for the 2026 to 2028 phase. During the cash-intensive certification phase, the Department of Defense is providing vital, non-dilutive liquidity. Military subsidies are effectively functioning as a shadow venture capital arm. Under the AWorks Agility Prime program, Joby Aviation holds a potential contract value of $163 million to evaluate tactical logistics and medical evacuation. But defense evaluations have exposed a technical reality. Current battery electric platforms lack the range required for Pacific theater logistics. This demand to overcome the distances of military theaters is forcing manufacturers to develop secondary hybrid electric and hydrogen fuel cell pipelines. Defense funding acts as a bridge across the certification phase, shaping the long-range technology pipelines that will eventually reach the civilian market. The cautious U.S. experimental timeline lags behind more aggressive state-supported programs in Asia and the Middle East. China's EHang is already flying ticketed, paying passengers on established commercial tourism routes today. The pragmatic reality for the 2026 to 2028 U.S. launch is a focus on cargo logistics, rural medical transport, and Department of Defense evaluations. The subsequent phase through 2035 will likely consist of premium airport shuttles, constrained by the cycle life limitations of first-generation batteries and the need for pilots. Mass scaling depends on three technological leaps: commercializing solid-state batteries, approving autonomous flight algorithms, and building grid-integrated vertiports. Converging these three developments will drop the cost per passenger mile to displace traditional ground transit. The eIPP is a calculated empirical stress test, establishing the ground truths required to define the safety protocols and operational standards for the national airspace.